Hey everybody, welcome to Bill Sky the Sea Guy, and this is going to be a continuation of our standard out, our STD out Printf video that was right before this one. And in this video what we're going to do is we're going to go over some advanced Printf features, also some other string features, and this is by no means the most advanced you can do in Printf, but it's kind of neat. It's something that people need to do all the time. Specifically, we're going to do the comma separator, the thousand separator, I should say, and the currency character. And we're going to do that using the locale for our project. And that's something that you may need to use if you want to do things in the euro or in the the mark or whatever it is that you want to do currency for. You need to do it based on the locale of the program running. So let's just get right to that code. Okay, so I'm going to start off with the same project that we finished with in the previous video on printing to STD out Printf. And if you didn't watch that video, you can try to keep up here. I really recommend you watch that video, write that code yourself, and then make the changes. So what we're going to do here is we're going to clean this up quite a bit. Let's get rid of some stuff that we don't need. We really don't need, well, my name might come in. We don't need this stuff. But we do need the interest year. We do need that interest information. And we're going to come down here. We're going to clean stuff up. This is examples of things we did. So let's go ahead and clean that stuff up. And just as a reminder, let's go ahead and save and build this. And then let's run it. Make sure it built it okay. All right, let's run it. Let's do a review of what we're looking at. Okay, so we did some stderr stuff, so we need to get rid of that. So let's go ahead and do that while we're doing this. Here it is right here. So there's our printf, fprintf to stderr. And I also believe we did another sprintf. Oh, maybe not. Let's go ahead and save and build this and run it one more time. Okay, so this is what we're going to change. So what we would like to do in this is that we would like to add 1,000 separators. That would be in the United States, that would be a comma after every third digit starting at the decimal point going left. And I would also like to put in a $sign. I would like to put in a currency symbol right in before. And even in C++, this isn't super easy. But there are some really neat little functions in C that you can use to do this. So before that, instead of just including a $sign, what if you want your program to be purchased by somebody over in the UK or in Germany or Italy or even Russia or Ukraine or Norway, any of those countries, China, any country over there, or even over here in Mexico, and they might use a different symbol. It's a currency symbol. So what you need to do is you need to enable the locale. So the locale is basically the location of where the program is running, and it's using UTF, Unicode format of characters. So it's a good idea to use that. So let's go ahead and pound include locale.h. And I'm going to go ahead and save and build this. Now the way we're going to do this is we're going to do this as compatible across operating systems as we can, because the last thing you want to do is write a program that will only run on Windows effectively. It won't run on Linux or on Mac, or vice versa. You don't want to write something that's just on Mac and then you leave out all that possible revenue stream. And there's something else that I want to add, which is kind of neat in C99, is this idea of the standard bool. Now, for those of you that know C++, there's a data type called a bool. Well, there is no such thing like that in C. However, what they did was they came up with the standard bool.h include file, which does define a Boolean data type. So we're going to use that in some space elimination functions that we're going to be doing in the code. So let's go ahead and just save and build that and make sure it reads it okay. And I have tested this both on Windows and on Linux. I haven't tested on a Mac, but it should work. So we're going to do as much as we can to stay compatible. Okay, so the first thing that we want to do, I'm going to create some variables here, because what we're going to need to do is we're going to need to move data around. So I need to create a couple of C-string variables. So I'm going to create a char, I don't know, $deposit buffer, and let's make that 16. And I'm going to create another one, which is going to be $interest buffer. And And you're going to see why we're making these in just a moment. And then I'm going to create another one called work buffer. And we're going to make that 32. And what I'm going to do is I'm going to make it to start off with a \0, a null terminator. And if you remember in the previous version, or the previous video, the null terminator is needed to tell all these C functions when to stop processing. And then there's one last thing we need. I'm going to create a variable from the conv structure called LC, and this is a pointer to the variable. So what this does is this structure allows you to read what is the current location that my program is running. Is it in the United States? Is it in, I was going to say Florida. I don't know why I said that. Is it in Canada? Is it in Germany? Is it in the UK? And that's what this will do, and you'll see that in just a moment. The reason why we're doing this for deposited buffer and interest buffer is if we save and build this program and run it, there's really only two columns that we want to include the thousands separator. There's the total deposits column and there's the interest earned column. Now there's no interest earned here that's that high, but there could be, right? So we want to actually create a character buffer, and what we're going to do is we're going to take each one of these numbers and we're going to convert it to a string. We're going to format it when we do that with commas, and then we might even add a $sign in front of it. And we're going to do the same over here. We also want to bring it down to 2 digits instead of 4 because most monetary values in a report do not have 4 decimal points. Okay, so what do we want to do here? So what I'm going to do is, the first thing I'm going to do is I'm going to set the locale. I'm going to calculate what the locale is. So I'm just going to do a thing here. I'm going to say set locale. It's a function. LCALL is a constant, means I want to get all of the locale information. And by simply making it null or just double quote, it'll mean the current location, not a specific location. Now I could put something like JPN in there. I could put different locales in there to say I want to do this because I want to force it to be in Japan. Now one thing that's interesting is, where is that located? Where do we actually go to find that information? Well, I've got some notes over here I'm going to bring up. And every time I find something new, I look in these notes. And on Linux and Mac, it's pretty much the same way. What I'm going to do is I'm going to open up a terminal, and I'm going to change directory to user share i18n. I'm not sure what that means. / and support. Oh, and you can see the locales directory. I'm going to change directory locales. And you can see all the different locales. I mean, there's just a ton. And each one of those is a different country, maybe a different location within that country. And I mentioned Japan a little while ago. Let's see if we can find that. There it is. JA_JP. That is the locale for Japan. Now, there's also another file in there called supported. Oops. And this kind of has a list of all of them. UTF, that means that that's going to be a set of fonts, that's going to be a set of information, that's going to be a Unicode set, which means it's going to be much bigger than just ASCII or even extended ASCII. And if you don't know about Unicode, it's a whole subject. It's about internationalizing your program, and that's what that means. So you can see there's a bunch of locales. So you can look in that file, and if let's say I wanted to do Japan, there's Japan. This is the string right here that I would put in my code. And I'm just going to copy that. And then I'm just going to paste it in there. So now what I would be doing is I would be going to the Japanese locale. But for right now, this isn't a Unicode discussion, so let's just leave that blank. Okay? And so what that's going to do is it's going to tell my program I want to get the current locale, or I want to set the current locale to whatever my operating system is saying the location is. And then I'm going to say LC equals local, locale, yeah, local, not locale, locale conf. And what that's going to do is that is going to actually grab all the locale information and put it in the LC structure, which we created up here. So that's getting the current locale. Now, why are we doing all this? Because we need to know if there's commas for the currency separators, if it's a period for decimal points, if it's a $ or a euro sign for, the currency symbol. That's how we get that. That's how we create a program that is compatible across countries, across different locales on the earth. So what I'm going to do is I'm going to go ahead and build that. And instead of actually just printing out data, let's debug this. So I'm going to click on the debug button. And I'm going to put a breakpoint right here on the LC. I'm just going to double click to the left of line 36 in this case. And I'm just going to press the continue button. And it goes all the way down there, and I'm going to step over. Now let's take a look at LC. So in the debugger, we can look at LC right here, and you can actually see, excuse the pun, you can actually see that the decimal point is a period, the thousand separator is a comma. Let's see, we've got international currency symbol. We're going to say currency symbol. What is the currency symbol? It's the $. What is the international currency symbol? It's USD. So kind of neat, right? So you can get all the information about your locale. Now, as I said earlier, if you put, in this case, Japan in there, let's try that. I'm not sure if it's going to work. I've never actually, I didn't test this out. But let's go ahead and put that in there, and let's see what that information is. Again, I haven't tested this, but it should work. So let's go ahead and run this again, and let's continue. Let's step over that line. Okay, so we've got, let's see what we've got here. So it looks like the decimal point is a dot, but it also looks like we've got some null values. And probably what that means is that this is not perfect right here. So I'm going to stop this. And again, it's a little bit of a trial and error. It's really difficult, and on Windows it's even worse. So let's get rid of that space UTF-8, and let's save and build this again. And let's debug it and see if we get anything better. Yep, we're still having an issue here. I'm not really sure what it is. Again, I told you I didn't test this out. But this is one of those things that you have to figure out every time you start a new type of programming. I might even change that to JA_JP just to see what we get. But anyway, you can try that out to see what the different locales are. But for right now, let's just leave this null to say get the current locale. Now, it might be interesting to you, how is the locale set in the operating system? Well, when an operating system is installed, one of the things it asks you is, where are you? Linux does it, Windows does it, everybody does it. It might even ask you, can we use your current location during the installation if the operating system installed is smart enough to see your Wi-Fi or your hardwired network connector. So it might do that as well. It might do it automatically. But in this case, so that's information is stored in the operating system, and we're simply saying, please, let's just go ahead and get that. All right, so let's go ahead. Again, I always like to say, whenever I make changes, I like to save everything and build it. Okay, so the first thing that I would like to do is I would like to put commas in all of my numbers here. Now, we're only going to really see it in the numbers that are greater than 999. But let's go ahead and do that. And it's actually very, very easy. What we're going to do is we're going to come down here, and the two are total deposit and interest earned. So all I'm going to do is right after the %, I'm going to put an apostrophe, a single apostrophe. Now, this is the way it works on Linux. This is the way it works on Mac. I've tried this on Windows. Windows is not so easy. Windows does their own thing their own way if you're using Microsoft Visual C. If you're using MinGW, C and C++, works great. No problems. But the moment you move over to Visual Studio and you use Microsoft Visual C, they do things completely different, and actually it's not very easy either. So all I did was put a quotation mark right after the %. Let's go ahead and save and build that and run it, and voila, we all of a sudden have commas in our thousands. You got to admit, that's pretty cool. So, and you can see that in the printf documentation that the single quotation mark, and I don't know why they decided to do it that way, but the single quotation mark is used for that. Now let's go ahead and make these a little bit different. I'm going to make that a 2 decimal point. And I'm going to do the same thing down here. And this is the total interest earned. And I'm also going to put a single quotation mark for that value. Let's go ahead and save and build, because you can see, you might have seen down there that we didn't have commas in the total interest earned, but we do now. Oh my goodness, how nice is that? It was so simple to do that. So now we got to have those commas. Now that might be totally enough for you. In fact, it might not be a bad idea to do it that way and just assume the person knows that they're in their current country, and that's the total amount in their country. However, your boss may not like that. It may not be a complete solution on the report. So let's go ahead and add a dollar sign. Now, there's ways you can do that. I could do something like just put a dollar right here in front of every format number, and let's see what that looks like. Well, this isn't great, right? I mean, you've got the dollar, and then you've got your 15 character long wide column. It's not really part of the number, so I don't know if I like to do that. And also notice that you're using the dollar sign. You're not using the locale currency. So let's get rid of that. What would be really nice if we could put the dollar right in front of the first number of each value, or maybe put it in front, at the same position in every column, but closer to the numbers. So that's one thing we could do. I think that would be kind of a good idea. So first of all, how do I get the dollar sign? Well, one way to get the dollar sign is what I'm going to do is I'm going to put into work buffer. Actually, let's not do that. Let's actually look. No, let's put it in some code. So what I'm going to do is I'm going to actually put the dollar sign. I want to convert this into a string. Instead of just printing the number with commas, I'm going to convert it to a string, which is a number with commas, and then we'll stick the dollar sign in front of it. So we're going to call it work buffer. And that's where we're going to put all the... Actually, let's call it... We'll do the total deposit. So here's where we're going to start using our dollar deposit buffer. So instead of the total deposit, just using it as a number, we're going to convert it to a string, as I said a moment ago. We're going to convert it to a string and stick it in there. So let's just go ahead and do that. So, okay, here we go. So we've calculated our interest. We've calculated our deposit. Let's go ahead and copy. So what I'm going to do is I'm going to copy into the dollar deposit buffer. I'm going to copy LC. Remember, that's the locale structure, LC dot, and it shows the currency symbol. We could select the international, but we're going to select the currency symbol. And Eclipse changes that dot to a dash greater than. So what we've done is we've copied that dollar sign in this case, because I'm doing this in the United States, copying that to the dollar deposit buffer. And then what I'm going to do is I want to take the number. I want to take the total deposit number, because that's what we're printing on our report. I want to convert that into a string with commas. So we're going to use a new function here. We're going to use the snprintf function. And we're going to put that in the work buffer. That's where we're going to copy the number, put commas in it, and stick that in the work buffer as a string. So I'm going to say a work buffer, comma, and you have to specify the number of characters that your work buffer is. And I'm going to put the same formatting, just like I did in printf. I'm going to put a %, and what was it? I think it was .12 dot. Let's take a look at it. It's 15.2. So I'm going to say 15.2. We need to put that little exclamation mark in there to include the commas within the number, within the string. And I'm going to say that's total deposit. And that's going to go into the work buffer. Now you need to make sure that you type that in right. Okay. Now I'm so excited. I don't want to actually have to go through all the work of changing the entire report to see if this worked. So let's go ahead and build this, and let's just debug it. And what I'll do is I'll go ahead and turn off this breakpoint right here, and I'll put a breakpoint right there. And yeah, I've got a little warning sign here. Too many arguments for format. I'm not sure if that's true. Yeah, I'm not really sure if that's true. So let's go ahead and build that. Yep, and that, okay, I built it, that warning went away. So Eclipse doesn't always catch up. Okay, so let's go ahead and debug it. And I'm going to go ahead and press continue. And here we are. Now what we're going to do is we're going to look at work buffer. So I'm going to expand work buffer right here. And there's all the characters in work buffer. Notice it's all spaces for right now. Let's see if we can't drag that down. Okay. So our actual total deposit number, let's see if we can see that. That's 886.6999999. Okay, that's not a really big number, but let's see if we can make this work. So I'm going to copy it over. And work buffer, that's really interesting. Work buffer did not change. Oh, you know why? I forgot the F. I forgot to put the F there. See, that's why I love to debug this stuff first and to see what the data is. So let's go to put an F there. I'm so glad I made that error because it shows you the benefit of debugging. Okay, so let's go ahead and continue. Let's take a look at work buffer. Okay, there we go. Step over. Boom. There's our number. And our number right now has a bunch of spaces in front of it, but it's got 866.77. So it actually took that number, that floating point number, converted it to strings and added commas. Now this isn't big enough. Let's go ahead and press continue and see if we can get a number that's big enough to have. Nope, that one's not big enough, so I'm going to press continue again. Oh, it is 7793. So let's step over. Okay, here you go. So there's the 7, there's the comma, there's the 793.35. So you can see that SN printf function is doing what we want it to do. It's formatting it just like printf, but it's converting it to a string and sticking it in work buffer. All right, that's awesome. Okay, now what's the next thing we want to do here? Well, let's take a look at our code. What did we do? We copied the currency symbol into the $deposit buffer, so the dollar sign is going to be right in the front. What I'm now going to do is I'm going to say strcpy into, oh, that's the wrong spot. strcpy into dollar deposit buffer work buffer. So that's going to copy everything in work buffer into dollar deposit buffer, which has the dollar sign in it. And so that's going to stick the dollar sign in front. So let's go ahead and save and build that. Let's debug it so we can take a look at our dollar deposit. Continue. Step over. Okay, we're looking for dollar deposit buffer. Right now it's just got a dollar sign in it. Remember we copied that in from the locale. Okay, so it created, where's the dollar sign? Oh, I didn't concatenate it, I copied it. So I should have concatenated it because when you strcpy, it overwrites anything that's already in there. Boy, these are great errors I'm making. So let's go ahead and no, I'm not doing this on purpose. So strcat. This is how I like to teach at university. Okay, so let's go ahead and continue it. We're going to take a look at dollar deposit buffer. There's that dollar sign right up in front. Step over. And there we go. So there's the dollar and a bunch of spaces, and then we've got the number. So that's what we're going to print. Now, you may not want those spaces, so we're going to take a look at that in a little while. We're going to get rid of those spaces. I'm going to show you a really neat little trick to do that. Okay, so now instead of printing the total deposit, we're going to print the dollar deposit buffer. And instead of a floating point, we're going to say 15S. And then we come up here, make sure it's 15S. Okay, let's see how that works. And the reason we took away the single quote was because we don't need that anymore because we did it in the SNPrintf. Okay, let's run our program. All right. Okay, so here we go. So now we've got this $sign right here. That's pretty good. It's kind of off. It's kind of pretty far out there. Well, how can we fix that? Well, what I can do is, instead of saying in the SNPrintf, instead of saying 15, I'm going to say 12. Let's run it. All right, this is looking a lot better. In fact, this is a really good way of doing it. Put the $sign on the far left of the column. And I didn't have to change the printf, I changed the SNPrintf that went to work buffer. So let's leave that there for now. So now let's go ahead and do the same for our interest earned. And the way I'm going to do that is I'm just going to copy all of this. And I'm going to say interest earned. I'm going to use interest earned. And I believe it was, actually, what was it? It was $interest buffer. And I think that should be it. So let's go ahead and save and build that. And let's run it. And, oh, it still shows the non-dollar because I'm still printing interest earned. I'm not printing $interest buffer. And we also have to change this to an S. And there it goes. It looks pretty good. That's a pretty good report. But what if you wanted to stick it even closer to the number? Well, we could do it. There's a couple of ways to do this. We could change this from a 12 to, let's say, a 10. But you have to think, how big is your number going to be? Is your number going to be able to stay in a 10-digit or a 10 character? So this is looking even better. I think 10 is probably the limit unless your deposits are greater than $999,999. Now, for a large business or even a medium-sized business, that might happen, right, in an entire year. But, you have to think about it. You have to think about what would be best. Maybe 11 might be best. You have to think of what the business needs to do. But, oh, look at what we didn't do. We didn't do this down here yet. We didn't do the total interest earned yet. So let's go ahead and do that. Let's put the $sign in front of that. And the way I'm going to do that is I'm just going to copy those 3 lines of code and paste them right there. And I'm going to do the currency symbol. I'm just going to go ahead and use dollar deposit buffer because that's just a temporary thing. And I'm going to say total interest earned. And instead of printing total interest earned, I'm going to print dollar deposit buffer, and we're going to say 15S. And we no longer need that single quote. I want to make sure I get rid of that single quote now since I'm doing it in the SNPrintf. Okay, let's save and build it. Let's run it. All right, that's looking pretty darn good. I mean, that looks like a really nice report. And you may just decide to leave it there. Well, one thing that I don't like to do is I want to have multiple ways of doing things. I don't like just one way of doing things. So what I'm going to do is I'm going to show you how to write a little function in C that allows you to take away the spaces before and after a number. And the way I'm going to do that is I'm just going to, I've got the code already written over here. I'm going to go ahead and just copy and paste it into my program, and then we'll quickly go over the code because it's always a good idea to go over this code. And let's just go ahead and paste. And what I'm going to do is I'm going to create a function called remove leading and remove trailing. Now you might want to change that to remove leading spaces, remove trailing spaces. And because there really isn't anything in C that lets you do that easily. You might be able to use special character processing. I'm having a senior moment as to what that's called, but you might be able to do that. But let's do it in code because I really like solving these problems myself. So what I'm going to do is I'm going to copy the function. So up on top I put the actual function prototypes, and then down here I'm going to go down to the bottom and I'm going to paste the actual functions. So let's take a look at what these functions are doing. So let's zoom in and let's walk through each one of these. So the remove leading function, it's going to take a pointer to a C string, which we're going to call the string. So that's the string that we want to send to the function to get rid of all the leading spaces. Then we have the length of that string. We kind of have to know what that is. I guess you could look for \0 to find out when you're done, but why look through every character if you just are trying to get rid of the beginning spaces? I've got a couple of variables here, current position and start position, because what you're going to do is the function goes, it's going to start at the beginning and it's going to keep going until it finds a non-blank location, a non-blank character, and then it's going to need then the start position. You'll see that in just a minute. And then here's where this Boolean is. Now the reason I have that Boolean there is because once I get past all of the leading spaces, I actually want to start copying data, but I also want to copy spaces. I don't want to ignore spaces that are in between words or numbers or whatever. So we want to turn that on. So what I'm going to do is, the first thing I'm going to ask is if the length of the value is less than 0, or the string at position 0 is \0, which means it's a null string, there's nothing to do. So I'm just going to return. And notice this doesn't return anything because the actual string itself is going to be modified, or the C string. So then I have a while loop that says, while current position is less than the length. Notice I set current position equal to 0. So in this case, if the length is 16, is 0 less than 16, yes. Then I ask, is the string at the current position equal to a blank, and am I not just copying? In other words, I'm going through and finding the first non-space character at the beginning of the string. I go to the current position ++, so I go to the next position. What I'm doing is I'm finding the first non-space character at the beginning of the string, and then once I get there, I'm going to start copying it to the beginning. So I'll be laying the same string, or the same character in the string. Okay? So then if the current position is not equal to blank, then I'm going to say the string at the start position. So remember, start position starts at 0. So let's say there were 5 blanks in front of your string. It's going to go to the 6th character. It's going to find out that's not a blank. So it's going to copy that to the 0 position. It's going to copy that to the front. So we're going to shift all of the bytes to the front. I increment the current position so I can look at the next one. I increment the start position because now I'm copying. And I say just copying is equal to true, so it won't do this anymore. And then it ends. Then the function ends. The next function is going to be called remove trailing, and what this is going to do is this is going to start at the end of the string, and it's going to grab every space and override it with a \0. So it'll just remove all of those, and that's really all it does. So the first thing I do is I say current position equal to the length of the string -1. I check to see if the length is less than or equal to 0, or if the string is null. I return. While the current position is greater or equal to 0, I ask if the current position is blank, or the current position is equal to negative or equal to \0. To reduce the amount of lines of codes in this, if it's \0 or if it's blank, I just override it with \0. I go to the next previous position. Once I find a character that's not blank or \0, that means I have found the first non-space character. I just break out of the while loop and leave. So let's do that. Let's use those functions. So I'm going to remove leading. I'm not going to use the remove trailing, but I'm going to use the remove leading. Okay. So in work buffer, we put the total deposits. Let's get rid of all of those leading spaces. So I'm going to say remove leading work buffer. And I believe work buffer was 16, right? Oh, work buffer is 32. Oh my goodness. So let's put in 32 here. So that's going to modify work buffer, and then work buffer will be used there. Let's do that for the same thing down here. And now let's see what our report looks like. So now the $sign is right up against the number, which is maybe what you want. Maybe that's what your boss, or maybe that's what you want. And so by doing that, you can, by creating your own function like that, you can then manipulate the C language to do that. All right, pretty neat, right? I showed you how to include commas in your printf, how to include the currency symbol, where to find the currency symbol. I made a comment about special characters, about being able to get rid of spaces and strings. For a moment there, I forgot what the name of that's called regular expressions. So there might be a way, in fact, I'm almost positive there is, to remove spaces from the beginning of a string or the end of a string using regular expressions. So that might be another one. But instead of having to learn regular expressions, we just went ahead and threw together a couple of functions to remove leading and remove trailing spaces. Something that you can use in your C library to really make your applications hum. So I hope you enjoyed today's video. Hope to see you at our next one.